So thanks again, everybody. See how I can change page. Okay, this way. So some of you, if not many, already should know me. I have been in the NCAR high performance computing user. Sorry, I couldn't hear what I couldn't understand what you were saying. I don't know if there was background noise or you were asking a question. So if it's a question, you may try to be closer to the mic or maybe type into the chat. And what I was saying is that, I am in the user support section for more than a decade now. And this is a large group, so we'll see how it goes. But soon, as far as I am concerned, it's fine to interrupt me if you have a context-relevant question that you want to ask right now, and maybe you can raise your hand or maybe ask it that into the chat. And there are a couple of people doing moderation, so hopefully that doesn't become too unwieldy. If it does, then maybe we'll save all the questions for later. So with that, let's get started. And before we start talking about JupyterHub, I guess, at least for me, before I was using JupyterHub without even thinking what it was. So I say, after a while, I say, well, let me check what it is. And I think it's important for having even this very basic understanding if you're using it. So JupyterHub is what's called the way to serve Jupyter notebooks for multiple users. And so Jupyter notebooks, then, if JupyterHub is the way to serve Jupyter notebooks, then the question raises, well, what is a Jupyter notebook? Well, a Jupyter notebook, and maybe then we'll go back to JupyterHub in a moment. But the Jupyter Notebook is a single user web application that it's used to create documents and those documents containing, live code that you provide and type or load from your machine, equations, visualization, graphics, text. And maybe you have already been using it, and you could use it for data cleaning, data transformation, doing maybe not too heavy or sometimes even heavy numerical simulations, statistical modeling, and basically anything. It's code, so you can code whatever you want. Now I have highlighted here the arbitrary user-provided live code, just because that. While you talk to security, for example, and maybe right now they know about Jupyter Notebooks, but when we started this conversation with security, you say, well, the point of Jupyter Notebook is to let whoever is logged in execute arbitrary code. And that's exactly what security doesn't want, because a web application by definition is open and potentially to anybody. I mean, of course, you have to log in, but if there is a hacker can get in, they don't want that. So usually web applications are secured against that. And so there was a problem, and it was a problem, but so that at the beginning we couldn't solve. And so there was an old version which you might have already used on Cheyenne, maybe even in Yellowstone it was installed, and in which you could run Jupyter Notebook in another way. And that other way requires a clumsy setup. You have to log in twice, do an SSH tunnel, and that in a sense is more robust, and maybe we'll have a look at it later if there is interest in that. And so I encourage everybody to become familiar with it, even though you might not want to use it that way because it's more inconvenient. But in that way, you are not exposing our supercomputer to the web, because you access the web via SSH tunnel in the same way that you access it to get a shell. So that's why the old one existed and still exists. But this new way that we will get back in a second is much more convenient, and it is so convenient. I will just share these two plots that are, the number of unique JupyterHub users per week and per JupyterHub sessions. So the session will be for several users. And as you can see, there are, more than 100 users in a given week, different users, not repeated. And each one of them use maybe an average of 8, use it an average of 8 times per week. So maybe an average of once a day or more, including the weekend. So it's pretty popular. And I expect, you see some spikes there, and there were some workshops that happened, and you see some drops, and there were some downtimes that we had. And you see this trend that's growing, and we can identify, we announced this or we announced that when the trend increased. So we expect that after the stock, maybe to see another trend up. So we are having the stock, but in the stock, I will not cover all the documentation that we have. We have plenty of that. It's still work in progress. I think, I have to praise our documentation specialist that does a really excellent job on organizing documentation and keeping always up to date. And it's always a work in progress, but it's a work in progress because it's becoming better. So that was the screenshot, and these are the links. The slides will be shared, so you don't have to make a screenshot now, but you will have the links into the slides for all these that are available at the moment. So let's dive deep into it. So the first thing that you do, you log in by finding your browser at jupyterhub.ucar.edu. And if you want, you could do that now. Let's see if I still sharing the screen. Can I go to this other tab? So can you still see this? Can somebody confirm that you see now, the JupyterHub webpage? And not
yes, Davide.
Okay, perfect. So here, when you point to that page, you will go to this introductory, landing page where you can choose which machine you want to use. If you want to use Cheyenne or Casper. I should point out that Chrome and Firefox are supported, are recommended browser, and Safari is not supported, and as far as I know, it doesn't even work, and that's a JupyterHub itself. It's a bug, if you want, in JupyterHub itself, so that doesn't work. So don't be surprised if it doesn't work. Change your browser as a first step, check into the back. So the first thing you do, you click on which machine you want to use. And in most cases, I think, not all, but in many cases, users want to use Casper because it's a more visualization machine and it's more suited for what Jupyter is made for. But on this example, I will use Cheyenne also because if everybody watching wants to follow me, then I have 82 of them, and maybe Casper could accommodate 82 users, but maybe not 82 more on what's the normal workload. Whereas for Cheyenne, I think 82 more is fine if everybody wants to do that. So once you get in there, it asks for a username and password. But before that, I want to highlight this sentence down here. It's a little small, but it says that this is access to the Cheyenne supercomputing via JupyterHub. It's in beta, so it's decently robust and it's working well, but it's not as well supported as all the other ways that we have to access the machine. Like SSH, normal SSH access. So you go there with your username, and that's the same that you would use for accessing in SSH. So you will have whatever your username is, and then you use Duo basically. In my case, I use a YubiKey, Duo with YubiKey. So I partially type something and I partially click the YubiKey that types something else for me. Not typing at that speed, that's a YubiKey. And it should log in. It says still waiting. Let me try clicking again. Well, if that doesn't work, I have backup slides, but it should work. Let me check on another shell that I have if ever.
Then is it because we have too many users? Because me, I keep timing out. It will just do like you. It's just turning and then it will time out. I don't know if it's the number of users, the 82 participants, that's doing an issue. I don't know.
Well, 82 is not an issue for Cheyenne. I don't know if it's an issue for the front end, but it shouldn't, unless we are all typing, signing at exactly the same moment. That may be the issue. Let me check here. Okay. So it is getting this. That's the same timeout that you were getting, the gateway timeout?
Yes, it's exactly the same timeout. And I see other people, I put it, and I see other people in the chat saying that they get the same timeout.
Well, maybe we stagger ourselves. So let me, you don't try anymore, and I just try myself. So you can watch what I say, and then you do it in a moment. See if that makes it easier. Or sometimes, you know, there might be issues, and there might be some issues that it's not working now. I can try the DAV too, I guess, while this does its thing. So if I go to the same URL and I go into the DAV, okay, well, let's go to the slides that I created in case this happened. I wasn't really expecting this to happen. I made them more for, you know, for people that didn't want to watch or want to just have the slides. So this is what I just showed. This is the beta we just said. And then once you log in, you go to this page. That tells you that the server is not running. So what is a server? You know, we were discussing, you know, JupyterHub itself and Jupyter Notebook, and now we are talking about a Jupyter server. Well, the Jupyter server is a program that responds to HTTP requests, and that is for a single user. So this is the Jupyter server is the same program that you can start yourself in the old way, you know, with the SSH tunnel that I described before, or maybe you can do that on your laptop if you run Jupyter on your laptop, you know, locally. And the way that the Jupyter server is configured, it's in usually inaccessible way from the outside, because the Jupyter server itself is not made secure per se. So, to make it both accessible and secure, you need some other layer on top of the Jupyter server to make it accessible, as I said, first of all, and secure also. So the way that we were doing before was with the SSH tunnel. We were just exposing the particular node in which Jupyter server was running to your local machine. And alternatively, in the way that we are using it now, instead with JupyterHub, it's the multi-user program that makes a pipe between the Jupyter server and the outside world. Now let's see if any of these has that. Does okay? So this didn't work. I guess we can go here and go full screen this way. All right, so after, you know, you would be here, and after that you will click that launch server, and will bring you to this page. In this case, is for Cheyenne. There will be a similar one for Casper, but there will be, you know, Casper uses a Slurm queuing system, so the form will be slightly different, besides saying Casper, but it will also different in thing. And it will ask the same, I mean, maybe not all, but most of the important things that you would specify on a normal PBS or Slurm job. So the only mandatory one that you have is the project. All the other ones have some default values that are, you know, reasonable default. The one that I want to point out is the walk clock limit, because here you're launching all the effects. You are launching a normal batch job, so that will have a walk clock limit. And after that walk clock limit, if the job isn't terminated by itself, which means you have exited, it will be killed, and so, you know, you will be kicked out of your session. Now, Jupyter itself tends to do some autosaves, so that, you know, even if you don't do the autosave yourself, it shouldn't be a huge deal. But I wanted to point this out because that's important, and some people might overlook it. And then, of course, there are all the other things that you have here, you know, how many CPUs you want to use, and if you're on Casper, if you want to use the GPUs, and how many of them, and so on, and the memory. So you might ask, well, why do we want to submit a job? And can we just do that on the login node? Well, the answer is we could, and we are actually discussing, and probably in the future we will allow that. But as normal for any other activity on the login nodes, you know, you will be limited by whatever you know, the use policies are for the login nodes. As such, you know, you might want to have a more intensive processing, or maybe, you know, machine learning things with the GPUs and whatever. If you submit a job, you have a node, maybe, I mean, node if you have an exclusive job, and then by the default here, you go on the share queue, so you don't have a full node. But if you decide to use a full node, you know, you will have all the memory, all the GPU, all the CPUs that you decide to allocate. So after that, you will be presented with this interface. And in this interface, you have the option to launch a kernel for a notebook. So you have all of these icons here, and you can click on one of them and launch the kernel. So again, you know, we have lots of terminology here. What is a Jupyter kernel? Well, the kernel is the program which interprets what you type, and so if it's part of the executable, you know, it executes it into the language of choice, for example, Python, most useful. And you say, well, I mean, isn't that Python itself? Well, somewhat, yes, but the kernel does something more, because it keeps the session in scope. So, you know, if you assign a variable and then the prompt returns, you know, the value of the variable is kept, is not lost. Like if you type, you know, Python quote a equals something, then when the prompt returns, that variable goes out of scope. Plus, you know, it does the formatting. If you do the text, you know, the equations and all that kind of stuff, you know, the plot visualization in the browser, it does all of that. So you have to start the kernel, and so what kind of kernels you can choose? Well, there are 3 varieties of kernel, at least that I know of. There might be more. So the first one is the ones that are provided by NCAR and particularly by CISL. And actually, there are 2 kinds of these, and I will talk about that in a moment. And plus, there could be 2 other kinds that you provide, and I'm separating those in 2 different ways, because the first one will be, you know, hybrid. So you start for something That's the ones that are provided by CISL, and then you maybe add or remove some packages on top of that. Or you start with a fully fledged Conda environment and you create on your own, and the ones are created by CISL that you modify are not Conda environments. So you can do that, and the documentation covers a little bit of this. Okay, so well, how do you choose which kernel to use? Well, the first question you have to ask yourself is what programming language you'd like to use. As you can see in that screenshot, you have Python, you're gonna use Bash, you're gonna have C++. Actually, you could have Fortran, even though the Fortran kernel is not installed because nobody asked so far, but there is a kernel for Fortran that exists. I haven't tried it myself, so I don't know how stable it is, but it exists. There is Julia, MATLAB, and many others. So the first thing is choice of programming language. Second, some programming language, and especially Python, and a little bit I think R too, have different libraries, and sometimes some of those libraries are incompatible with each other. So if you have one library, you cannot have another one. So for these libraries on the normal shell, we use the NCAR pylib script to select which set of libraries you want to use. But here instead, the kernel will be kind of all one thing with a version of Python or version of R and the corresponding libraries that are included with it. So the second question you have to ask yourself is, what libraries do you need? So after you have answered that question, then you can click. So for example, here there is this Python tree here, which is, it doesn't say exactly which subversion it is, but it is the stock Python provided by the Miniconda plus I don't know how many other libraries on top of that. Whereas there is this other one, NPL1, with a UCAR logo, which is Python 3.7.5 and has exactly the same environment that the NPL 2020 and whatever other numbers are there. I can't see that small numbers here, but they will be bigger on the browser. So that will be the same that you could load with the NCAR pylib script that we have on the shell. So if you click this one, you go there. You will load that specific environment. So once you click that, you will be presented with an interface like this one. Now in this particular screenshot, I have a Julia code. So this might feel a little not familiar if you're not a Julia programmer, and I know there aren't very many at NCAR. But in Python, it will be basically identical. So with the syntax that you type things here will be different. You type something and then you hit enter, and you go in here, and so it responds with whatever will be responded, on the screen here on the browser, whatever will be responded on the shell. And then if there are plots, the plots will be displayed here too. So one other option, if we go back to this slide here, there is a console section that has the same kernels as the notebooks. So if you click one of those, you end up in a console, which is something like this. It's basically similar to a notebook, but while in the notebook, it's basically a living document that you go back and forth, you can change things in the past. The console is more linear, so you cannot go back and just always go in the future, more or less like you might be more accustomed with a shell. So that's the main difference. So if you are just doing something that you don't plan to go back, or it might become confusing when going back because you changed the variable at the end of the code, say that you change the value, and then you go back here and you execute this again. Say that you have another line here. Let me do it in this one. So if in another box down here I change some values, and then I execute this box again, which in the list of the document is before, these output here will be different, and it might be confusing if you don't know the order. And in fact, what the notebook does, it adds here then some numbers that tell you what's the order that they have been executed. So in this case, it puts the same numbers, but you cannot go backward. So that becomes a little bit more clear on how things go. And then there is another list that wasn't included into the screenshot, after the console, that's shell. And the most important shell that there is actually bash. And so you have here the same interface that you would have. I mean, this colored prompt is what I have configured myself on Cheyenne. Yours might be different depending on how you configure it, if you did. It's not the default that we get when you get an account. And so, can do ls, and what else you can do in a shell. Now, the only difference that I want to point out is that here in my shell, I point out that I want to know which node I am. And so this shows that I am on node R6, I6, whatever. And that tells me that it actually is a batch node. And that's obvious because I submitted a batch node, a batch job. So that's running on a batch node, and it's not on a login node. So I am actually paying, in some sense, the allocation because I'm using this one in a, like when you do a queue interactive. So I wouldn't use this as the normal way to log in, but it has turned out for me convenient in a few times that I needed to do something in an emergency on a machine that wasn't mine and didn't have a working SSH installed, so I could just log in from the browser. So that, I think, it's sort of priceless, but you pay the allocation, so you have to have enough allocation for doing that. So that's the demo. I mean, it's a fake demo, obviously. Maybe we can give it another try. So let me go back here for a moment and see what else do I have. Okay, so I have some sort of conclusions. So let me state those and then decide where to go next. So the documentation provides additional details on all this that I covered today, and many other things that we haven't covered. And then, the next step is, well, okay, now I have the Python running there, and what I want to do, maybe I want to do a particular kind of analysis. I strongly suggest that you check out Pangeo. The Pangeo project provides, specific information for parallel analysis and many other use cases that are very appropriate for what all the researchers here do. I am planning to have a future talk on kernel customization, if there is interest. I think there is, but that's my guess. So that brings me back to some other things that we are planning to do, which the ability to load modules before the kernel starts up. Right now, you cannot load those modules before. So if you load it after, that's not the same. And so for some use case, for example, you want to use a specific version of NetCDF that you need to load the module, it becomes tricky to do. So that's not supported at the moment, but we are planning of making that available. Then there is a little bit of confusion that I've heard from some users when there is that list of kernel logos at the beginning. All of those are dumped into the same list. So I mentioned those 3 categories, and all of those will show up together sorted, I think, alphabetically. So, for example, you might have noticed that there was a kernel with a logo of an arrow that I made, and there was a test that I was making, and that one lives in my home directory, and there is no way for you to tell from that screen which kernel is which one. So you have to be very careful on the names that you use and the logos that you use. So what we are planning is to have some overlays, maybe the UCAR logo and transparency on top of the other logo, the normal logo it is, so that it will be clear which are your kernels that you created and which are the ones that we have created, to make it, that's just an example. There are some other few, friendliness issues that we're working on. And then last but not least, we are always working on documentation, as I was saying, and training. So if you let what you need, and that will be, more likely that we provide what you need instead of what we think that you need. So that's all I have. And in tying up with the last item that I just mentioned, there will be a quick survey that PJ, I think, will send you after this is done with the recording, and I think that email will contain also a link to the recording and to the slides. So if you fill that survey, we will know how this went, and if you need something different. So as I said, the slide and recording will be provided, and I guess that's what I have, right? Yes. So if you have questions, I'll be happy to stay around. I get it went a little bit shorter because it didn't work. So let's see, maybe I'll give it another try while people decide and what to ask.
Davide, while you're trying to log in, may I ask a question?
Absolutely, yes. That's what I'm saying.
This is Julian Chastain from Unidata, by the way. Do you have a feel for what your users are doing? So you displayed a graph at the beginning of the talk showing that you had strong usage on this JupyterHub. Do you have just some examples, or do you see trends of what users are doing with this specific JupyterHub?
I don't personally, but there are other people that are looking into that, and particularly for the Pangeo, the Pangeo representatives here. So they are doing development of some aspects that are of interest for NCAR. So I don't know if that answers your question.
Do you think that they're doing data-centric operations? Like, I mean, they probably have large data sets on Cheyenne generated from the models. Are they doing work that surrounds data that's already on Cheyenne?
I think some are, but not the vast majority, as far as I know. That doesn't mean that I know everything. So one thing that I was surprised to learn is that there are not very many using MetPy, for example, to say something that's developed in your data. But I don't see why. I don't see why not. Might be because it's more convenient to do that on your laptop, and it's efficient. Laptop might be big enough for what people are doing. There might be a reason. One other thing that I know that it is happening instead, it's not very feasible on the laptop, is you're doing machine learning, and there aren't very many people doing it, but there are a few. And if you do into, so this is not working, so I guess there is no point of staying here. Let me go here. And there are people that are, when you go to Casper, so if you select the Casper, then you can check the GPUs and We have some, not many, but a few nodes with very powerful GPUs, and you can use even more than one, and TensorFlow and whatever. And so that's, some people are doing that.
I have a question.
Go ahead.
So if you download and install your own Anaconda and create environments, does that conflict with this use of JupyterHub, and or are they available to JupyterHub?
If you just create the Conda-based environments, they don't conflict, and well, they don't conflict in either way. But if you just create them and don't do anything else, they don't show up. To have them show up as an option, so let me go maybe to this screen here. So in this screen, I think all of these, but there's arch and arrow, are stock kernels available to anybody. This one is one that's installed by me in my own home directory, and this has been created by making a clone of one of these, I don't remember which one, and adding a few other libraries, including one that's called Arrow. So I put this logo just for me to remember that I needed to do some test. So if you just install the, back to your question, if you just install the Conda environments, they won't show up here. However, if you do another step, which I don't remember at the moment, but I have it in our documentation, and I have the link to the documentation here. Here it is, this Conda environment. So you have to do this Conda install ipykernel. Once you've done that, magically, that environment shows up into that list. I haven't tested it myself, but I know that many people have done it, and it works.
So I did an install of Anaconda, and it put stuff in my dot files.
Okay.
Does that have anything to do with Jupyter, or do they just ignore your dot files in your environment and do the right thing?
No, I think that stuff that Anaconda puts in your environment is just for having, you know, the Conda into the path. So you can call Conda activate. I think that's the only thing it does. But I'm not a Conda expert myself. So.
Yeah. Well, I mean, hypothetically.
I know, so let me, I mean, I'm not an expert, but I know two things that are, I think, important and answers your question. So the first one is that there is no conflict. So if you do install Conda environment, there is no conflict whatsoever with either other environment. Well, with other environments that are there, depend on the order and the path. So depending on, you know, you have to check what it does in your dot file, because you might use one Python or the other, depending on which one is first on your path. But if you're careful selecting that, I think you're experienced enough that you can go there and see which Python you're using. If you're using the one from Conda or the one from the module load Python, then you figure out which one you're using and which one you want to use. That's about the conflict. And the second,
I could figure that out I guess by looking at my path and my environment variables, but I don't know what Jupyter's doing. Is it using that same path? So
no, it's not using that same path, and that's why you need to do this other thing, which does some magic, and I don't know exactly what that magic is, but some other people know, and that's why I say that there was a next talk about Conda environments, and not only Conda but also other environments. Because I wasn't prepared for fully answer the question, but I do know that it works. So if you do this command that I highlighted here on the screen, it installs something, not that you use only that environment, but that environment becomes an option here in the list. Let me go this way. In the list that you see from here. So once you've done that Conda install kernel, you will see here that other kernel, that other kernel as an option. And you might want to investigate how to make a logo and how to make a nice name that doesn't get confused with something else. And it was on my to-do list for the next talk. So if there is interested, I'll be happy to do that, or maybe I can investigate that and follow up with you privately, or you might just find it yourself now that you know that's possible.
Okay, thanks.
Sure.
Okay, Davide, we got another couple questions that have come in on the chat. First one is, for reproducibility, if the environments are updated, how can we access the old environments?
That's a great question. And in fact, there is a little bit of tension between the different maintainers of these environments. So as far as I am concerned, these environments that I said, that the ones from NCAR come in two flavors. The first flavor is the exact same that we have on the machine with a NPL and a date. So the NCAR Python library, I guess. And so these might become hidden if we decided they are obsolete and don't need to be advertised anymore. So we may hide them, but they won't be deleted. And it might be until the machine leaves. I don't know, when we decommission, we'll probably don't save those. And so that's one. And the other ones, like this one, that's a Conda environment that's provided by, let's say, the stock install of the JupyterHub configuration, and that might get updated. So there might be a concern for reproducibility if you use this one. And then there is a third option, of course, which you might manage your own environment. You create your own, and that's yours. You do with it whatever you want. So it's in your home directory by default, unless you put it somewhere else. And that it's backed up, so you don't have to worry about being deleted unless you delete it yourself. And even so, you can always check with the backup if it's not too old. A couple of weeks, backups will be able to figure it out. So I don't know if that fully answered the question, but hopefully it's good enough.
Okay, thanks. And then the next one came in was, let's see. I have had this issue for a few times. I get the message, server stopped running even when it hadn't hit the wall time limit. Is there a reason why this is happening, for example, due to inactivity?
No, there shouldn't be a reason due to inactivity. There could be a reason for if the job, so I guess there could be two different issues. The first issue is the job itself has terminated. And so if you are logged in or you log in separately into a shell and you check your running jobs and you see if there is a, let me go to, when you submit a job, you have a job name here. So by default, the name is Jupyter. So hopefully that's unique enough that you can find this job. So if the job is still running, then there is one issue that I will describe in a moment. If the job is gone, then it's a different issue. And most likely, in this second case, could be either the walk clock has been passed, or you have exhausted, some other resources, such as memory, that made the job crash, or maybe the job has crashed for, for a bug or some other reason. So that's the second. The first, if the job is still running, there could have been some connection issues, and actually I've seen that happen a few times, and we're working with the system administrators to figure out why this is happening, and if we can do anything to prevent, and B, at least as a temporary workaround, how to reconnect to a running Jupyter server from the hub without needing to kill that job and submit another one. So hopefully that answered the question. And it's a little bit of work in program. That's part of the beta. If we wait for this to be ready and so that there is no issue, then maybe we don't need it anymore because it's too late.
I'll go to the next question then for you, which already has one response from one of the other users here. But the question was, I have specified the environment variable Python path in my bash RC to use my own user-defined functions. How can I do the same thing in JupyterLab?
Well, that's a part of the future work. I mean, I didn't mention explicitly this one, but it's the same issue with the ability to load modules before the kernel startup. This, at the moment, is not possible. So if you can live with it after, so one workaround could be that once you have your running Jupyter notebook, I think there is a sys.path something that you can set up and say, take the libraries from this other directory too. So it's part of the system module in Python. So if you import sys and then in the sys, I think it's path, but I'm not 100% sure. You can manipulate that path after the fact. So for this particular one, but if you want to do something more sophisticated that actually needs to be happening before the kernel even starts, that is not supported at the moment.
Ricky Eglin responded to that question saying, I have started updating sys.path in my notebooks to replace what was done before with Python path. So,
okay. Yeah, so basically it's the workaround that I suggested for that particular thing, but there might be other environment variable that needs to be set up before, and so those are not available at the moment. So maybe I answered more generally than the question was. So maybe the question was more specific.
I think I believe the general question was answered. So I think we're pretty good, but we'll find out here in the chat.
Okay, thank you. Thank you for monitoring the chat.
Sure.
I have a quick question, if it's okay.
Absolutely, go ahead.
Yeah, hi, this is Abby. I'm from mCubed. And one of my frustrations with JupyterHub, and the reason I use JupyterLab, is that I can only launch it, I guess, from my home directory.
Yes.
And I don't know. I know this is maybe annoying and I could easily change it, but I generally do all my work out of my working directory. And that's why I like JupyterLab. So is there any plans to make it a little more accessible to access on the whole Glade system?
So this is part of the improved user friendliness, right? Okay. So it's on our to-do list. But for now, what you can do, let's see here. So this is the home directory you mentioned. So if I recall correctly, well, maybe not when I took the screenshot, but well, actually, yes. If you see here, I have Scratch, and this Scratch is a symbolic link, that I created in my home directory that points to my Scratch space for exactly the same reason that you mentioned. So I can go to Scratch by clicking on this one, and that works. So it's a workaround. It's annoying because you have to go there and create these symbolic links to every place you want to go. But that's what we have for now. It's on our to-do list to make it working more, nicely.
Thank you.
Sure. Anything else?
I have one more question, if that's okay, Julian from Unidata.
Yeah, sure.
Is this JupyterHub just one server and many users are hitting just that one server?
Well, there is the server. So if by server you mean the web front end, yes. But that web front end does not do basically anything other than preventing anybody from going in without first being redirected to the login page, which is on the, I think it's a Radius server. and then submitting a job to the queue. And so what it does is basically almost nothing. It's even less than what a login node does normally, and I think it has the same hardware similar to a login node. It used to be actually even more lightweight. So that's one thing that we have improved, making this node server more robust and with some automation and better auto restart. If the server should crash during the middle of the night, it should auto reboot and try to restart the thing automatically. But yes, it's a single server.
I'm just trying to account for those 504 errors, and I'm just kind of wondering if there's just any scaling going on under the hood. Like if this would be running on like a VM on Amazon or something like that, there would be a whole Kubernetes system, something like that, just spinning up additional VMs to accommodate more users. This is Cheyenne, of course, and so you get both the benefits of that, but also maybe some of the drawbacks, and then you can't do that sort of work. I'm just curious if you're running into too many concurrent users for this, for example.
I suspect that's not the issue because, as I said, that's not doing much. It's just basically, like the traffic, the person with the flag that say, you go this way and you stop or you go. So it's not really doing any work. It's only you arrive there and it redirects you to the login, and the login is on the radius, so it doesn't do the login itself. And then it redirects you to this page, which you actually start the server, which is running on a batch node. So the actual server is not the JupyterHub web front end. It's whatever it's running on the batch node. And so we have plenty of batch nodes. So what you do usually in Amazon with Kubernetes, you spawn more jobs because what you call server there, it's this one. Here, I mean, we're calling server too, but that's happening on the batch nodes. So I don't know what's happening there. I've seen it happen another time in the past, only once, doing that thing, and it was something that was system administrator issue that I don't recall because I'm not a system administrator, and it was actually an easy fix. Actually, I wonder if maybe somebody was, while I was talking, contacted, submitted a ticket, and maybe could have been solved. I don't. Oh no, sorry, that was not what I intended to click. Let's see. Any other question while I try for the last time?
Davide, when you, at the beginning of your talk, you had mentioned this, but a number of people hadn't joined yet. You might mention again our service, our SLA and expectations for support for JupyterHub.
Yeah, that's a good point. So I think I should have mentioned that more when I highlighted this one that says, this is in beta, so that there is no, there is no, not the same level of support that we have, for example, for the login nodes, that we have 6 of them, and if one goes down, somebody get paged, Christmas Eve or night or any time, and somebody's gonna fix it. Whereas for this, it's next business day.